Hello. Today I'm going to show you one way to model step 2 of photosynthesis, the light-independent reactions, or sometimes it's called the Calvin cycle. So just as a quick review, the first step of photosynthesis, the light-dependent reactions, happens inside of the thylakoid, where we have water and light goes in, and then oxygen is released, and the products are ATP molecules and NADPH, our high-energy electrons. And the purpose of step 1 is to create this energy that's going to be used to power step number 2, the Calvin cycle. The Calvin cycle occurs in the stroma, or like this liquid part of the thylakoid, of the chloroplast. So our inputs are 6 molecules of carbon dioxide, and we know that we need to make 1 molecule of glucose. We just have to figure out how. Glucose has 6 carbons, so somehow we're going to take the carbon from our carbon dioxide and rearrange it during the Calvin cycle to make 1 molecule of glucose. So the first thing that's going to happen is 1 molecule of carbon dioxide is going to enter the plant, and then it's going to combine with this molecule right here that has 1, 2, 3, 4, 5 carbons. That's called RUBP. So when they combine, this is going to become a molecule with 6 carbons, and we'll just let the oxygens hang out there on the side. And so that's our original carbon from carbon dioxide. It's marked. This 6-carbon compound isn't very stable, so it's going to break into 2 3-carbon compounds. That's called PGA. So this is 1 molecule of 3 PGA. This is another molecule of 3 PGA. If you like golf, that might help you remember it. Next, we are going to have reduction. So this is where we're going to use our energy from step number 1. So the ATP comes in here, and the electrons come in here, and we have a little bit of a carbohydrate scramble going on. And then what we're going to get in the end is a rearranged molecule. So I'm trying to represent using this energy to be able to rearrange what happened. So we're still going to have 3 carbons actually, but now that oxygen is in a new place, and this one has 3 carbons and the oxygen is in a new place. So even though this molecule looks similar to PGA, now we're going to call it G3P, and again, G3P. So the atoms are on the outside, the oxygens and the hydrogens that I'm not representing have been rearranged, but it still has 3 carbons. And because we used up all of our electrons, now this is low energy NADP+, and it's going to come back over here to the thylakoid. And we used up our ATP, so now this is ADP, low energy going back, ADP, low energy going back. So now we have this 3-carbon molecule, and now we're getting pretty close to making glucose. So one of these molecules of G3P is going to be used over here to be able to make glucose, and the other molecule has to get recycled. Why is it getting recycled, you might wonder? Well, we need to be able to remake that RUBP so that it can combine with another carbon dioxide molecule, because we have to do this 6 times to be able to make 1 molecule of glucose. So one more time, we will see reduction, step 1 is carbon fixation, where carbon dioxide combines with RuBP. An enzyme called Rubisco catalyzes this reaction. Then that 6-carbon compound is going to split into 2 3-carbon compounds called 3-PGA. Then the next phase is called reduction. That's where our energy is going to come in and get all used up. And then even though we can't really see it, what's happening is the oxygen and hydrogen atoms are being rearranged. And we end up with 3 molecules of carbon with oxygen and hydrogen atoms in a slightly different place. And this is called G3P. Now this carbon is going to leave. We're going to remake our UBP up here, and then guess what? It's going to happen again. Carbon dioxide comes in. It forms a 6-carbon molecule. It splits into 2 molecules of PGA. The energy comes in and rearranges it, and now we call it G3P. One of these carbons leaves, and then we reform RUBP so that it can happen again and again and again. So fast forward, pretending that all of these carbon dioxide molecules got taken in, and what we're left with is 1 molecule of glucose with 6 carbons. So all of this work we've been doing in photosynthesis was to make this 1 molecule of glucose.